Woohoo, we are live. Yay! We are live. This is Math 60 Intermediate Algebra. We're talking about factoring techniques. This is chapter 5. And we're at the end of chapter 5, which means we are looking at a summary of all the different factoring techniques. And then in 5.8, we will start factoring polynomials that require two or more techniques in a row. So you'll do one thing and then you'll have to do another, and maybe even a third or a fourth. So we're going to be working through some really complicated polynomials and trying to just step through and develop some techniques for how to approach it. So this first page doesn't have any problems on it. It's just a list of all the techniques. So let's go through. The first thing we're going to talk about is the key to all of this is going to be counting the terms. So I have organized all these rules according to how many terms there are. However, very first rule, always look for greatest common factors. So you look for anything that's common to all of the terms and factor those things out. It is never going to be better to leave that till the end. Never, never, never. Always do it first. So that's the first thing. Next up, if there are two terms, the good news and the bad news is it could be the sum or difference of squares. If it's a sum of squares, you can't factor it, you're done. If it's a difference of squares, it's relatively straightforward. If it's a sum or difference of cubes, however, that's when things get a little bit more exciting. And so what I would say is remember that these two formulas are easiest to memorize together. What happens if there are three terms? Well, if there are three terms, we're looking at a trinomial. Sorry, I don't mean to make everyone sick. So either you're using trial and error, that's this one, where we say, okay, if there's an X here and a question mark here and a question mark here, right? When you try to figure out what goes into all the spots. Or you could be using the AC method. That's when you multiply A times C and then look at B, and the formula was back in that section. Or you've got a perfect square. If you've got A squared plus 2AB plus B squared, that's A plus B, the quantity squared. And if you've got A squared minus 2AB plus B squared, you've got the quantity A minus B squared. If there are four terms, then you're looking at grouping. So that's when you do this and you do this and you look for, so there are four terms, you look for something common to the first two and you look for something common to the second two. That's going to be grouping. And overall, you want to keep factoring until x doesn't appear to a power greater than 1. So no x squareds, no x cubes, or you know for a fact, for a factor, anyway, you know for a fact that all the factors are prime. So keep going until you got down to either just x's or prime factors. And how do you check? Well, it's not always fun, but the best way to check is to just multiply everything out, see if you get what you should end up with what you started with. So shall we just dig in? Woohoo, yay, let's do some factoring. Oh boy, factoring for everyone. Factoring for teens. Sorry, it was a reference to one of my favorite shorts. It's called The Big Snit, from back in the 1840s, early parts of animation. Okay, so I've got a polynomial. Now I do notice there are two terms, so I'm looking at sum or difference of squares or cubes. But before that, I want to really make sure I'm paying attention to what's common. And I notice that I've got a 10 and a 40. So already I can see I've got 10 common. And then there's also an x in both of these. So if I've got 10a squared x minus 40b squared x, I can factor out 10x and end up with a squared in the first case minus 4b squared in the second. And you can use brackets or parentheses. You know how much I love brackets. So I love throwing those brackets in there every time I can. But you could use parentheses too. And now I've got two terms. I've got a minus, so it's a difference. And then I look and I see a squared, b squared, difference of squares. So then I probably want to have my a squared minus b squared equals a plus b times a minus b. So this will be a squared minus 4b squared. Okay, so the big trick here is going to be big A squared is little a squared. So big A is little a. So that's pretty straightforward. Every time you see a big A, you've got a little a. So it's little a plus, little a minus. Now, big B squared is going to be 4b squared. So you got to think, what is that? This is A, the quantity squared, and what is this? The quantity squared. So if I've got 4, then I must have started with 2 and then a b. 2b, the quantity squared, gives me 4b squared. So I've got a plus 2b, a minus 2b. 2b or not 2b. I'm sorry, I keep saying that. Okay, let's move on before I say anything else that's really dorky. Too late, right? Okay. This one is a twist. Normally, the death problem doesn't come till later on, but I decided to go with death right up front. Why not? Here, I've got bring some light in. We've got x to the 6th minus 64. It's two terms, and it's a difference of, and the thing is it could be squares. Oh, that's exciting. Or it could be cubes. Because 64 is equal to 8 squared, and 64 is equal to 4 cubed. And x to the 6th can be a square or a cube. 2 and 3 both go in x to the 6th. Here's the thing. If you approach this the wrong way, the quote-unquote wrong way, you won't be able to continue until you take another semester of algebra. There's some techniques that we haven't taught you, and this gets really, really, really complicated. So what I'm going to say is go ahead and do the difference of squares. So I'm going to say a squared minus b squared, a plus b, a minus b, and then I'm going to have 64 is 8 squared, x to the 6th is x cubed squared. See that? So then I've got x cubed plus 8 and x cubed minus 8. Now, some of you saw this coming. Oh boy, these both are cubes. This is a sum of 2 cubes. This is a difference of 2 cubes. So we can then expand each of these. Oh, joy. So x cubed plus 8 is really just x cubed plus 2 cubed. X cubed minus 8 is x cubed minus 2 cubed. So let's look at the expansion. I've got, if I have the sum of 2 cubes, let's see, do I have my piece of paper? Is there a way to bring this in such a way that you can see it? Not really. So let me just remind you very quickly. A cubed plus b cubed is a plus b, that first factor, and then a squared minus ab plus b squared. A cubed minus b cubed is a minus b, that factor times the factor a squared plus ab plus b squared. Okay, so let's use this. X cubed plus 2 cubed, x plus 2 times x squared, then we bring in the minus, 2x plus 2 squared. That's, so this piece right here, the x cubed plus 2 X cubed plus 2 cubed becomes those two factors. And then the x cubed minus 2 cubed, x minus 2 times x squared plus 2x plus 2 squared. That's this guy. And then, although I've kind of run out of space, I should clean this up. X plus 2, x squared minus 2x plus 4, x minus 2, x squared plus 2x plus 4. There we go. Oh, man. So let's take a look. Let's take a moment and think through. So what ended up happening was, because 64 is both a square and a cube, and because x to the 6th is both a square and a cube, we ended up doing difference of squares, and then all of this was sum and difference of cubes. So we actually had 2 parts and ended up with 4 factors. Okay, the last one will make up for that. Sorry about the bouncy table. I'm not sure why the table is so bouncy right now. Super fun times with the difference of squares. This is also 2 terms. 7x to the 6th plus 28y squared. We've got 2 terms. We've got a sum, and we've got a mess. Unless you notice, we can factor out a 7. Now, x to the 6th could be a cube, right? Because 3 does go into 6. But 4y squared is not a cube. This is a square. So we've got a situation where we've got x cubed squared plus 2y squared. It's a sum of squares right here. It's a sum of squares. It's not a sum of 2 cubes, so we're stuck. This is our final form. So this is it. The only thing that factors is the 7. Woohoo! Woohoo! Yay! Okay, that's it for the 2 terms. Next up, let's try wrangling a couple of, I don't know, trinomials, maybe even 4-termed polynomials. It's going to be fun.